Hi everyone, we're going to solve the equation on the interval 0 to 2 pi, sine of 2 theta plus sine of 4 theta equals 0. The first thing I want to do is look at this as sine of 2 alpha, and that would mean my alpha equals 2 theta, because if I multiply 2 times 2 theta I get 4 theta. And then I'm going to expand it using my double angle identity. So just copy down the first one, sine of 2 alpha, plus, now to expand sine of 2 alpha, I would get 2 sine of alpha cosine of alpha equals 0. But my alpha is 2 theta. So now I have sine of 2 theta plus 2 sine of 2 theta cosine of theta. All right. Whoops. Put a 2 there. All right. Now we're going to factor out the sine of 2 theta here. If you do that, you're going to get sine of 2 theta times 1 plus 2 cosine of 2 theta equals 0. I'm going to split this up and solve for each one. So I have sine of 2 theta equals 0. And then for this piece, I have 1 plus 2 cosine of 2 theta equals 0. Subtract the 1, so you get 2 cosine of 2 theta equals negative 1, and divide both sides by 2, so cosine of 2 theta equals negative 1/2. Now we're going to have to work on both of these, and I'm going to go ahead and start on this one. So we're going to look and solve for theta for this one. All right, so we have cosine of 2 theta equals negative 1/2. So cosine of 2 theta equals negative 1/2. Now if I look at this as alpha again, if I want cosine of alpha equals negative 1/2, I get these values here. So my alpha would be these two. Your alpha would equal 2 pi divided by 3 and 4 pi divided by 3. Since I need this to equal alpha for this to be true, I'm going to set this equal to alpha, which in our case is 2 pi divided by 3. And I'm going to go ahead and put our period at 2k pi. And this one's going to be 2 theta equals 4 pi divided by 3, because that's my other alpha, plus 2k pi. Now let's multiply through both of these by 1/2. And that's going to give me theta, to solve for theta. That's pi divided by 3 plus k pi. And this one's going to be theta equals 2 pi divided by 3 plus k pi. Now I have to find all the solutions on the interval 0 to 2 pi. So if k is 0, then we just have pi divided by 3 and 2 pi divided by 3. All right, let's look at k equals 1. K equals 1, we're going to get pi divided by 3 plus pi. Or I can write this as 3 pi divided by 3. That gives me 4 pi divided by 3. And if k is 1 for this one, we'll get 2 pi divided by 3 plus 3 pi divided by 3. And that's going to be 5 pi divided by 3. Now we can't go higher than that, because if my common denominator is 3, and we only can go to 2 pi, then I cannot go higher than 6 pi divided by 3. Because that is going to be the highest you can go. You can't even equal that. So that's our solutions for this one. Now let's do the one for our solutions for sine of 2 theta. And we have this equals to 0. So we want alpha equal to 0. So basically, if sine of alpha equals 0, that means where your y is 0, that means that's going to be my alpha is going to be 0 and pi. So, but we want 2 theta to equal 0 plus k, 2k pi. Because if this is 0, then I get the correct solution, or 2 theta equals pi plus 2k pi. Again, we're going to multiply everything through by 1/2, or you could just say divide by 2, and that's going to give you theta equals, we don't need the 0, just k pi. And for this one, we get theta equals pi divided by 2 plus k pi. So if k is 0, we get our angle equals 0. And on this one, we'd get pi divided by 2. If k is 1, if I plug a 1 in here, I'm going to get pi. For this one, I'm going to get pi divided by 2 plus pi. So put 2 divided by 2. That gives me 3 pi divided by 2. And we can't go higher. If my common denominator is 2, I cannot go higher than 4 pi divided by 2. You can't even equal that. So that's it for our angles. So we had 4 here and 4 total. So we have a total of 8 solutions. We had 4 for each of our factors. Thank you. Have a nice day. Bye-bye.